Hi there, Miss Barbara here. This lesson is titled Flaws of Voting Methods. In selecting a good voting method, it's nice to employ some sort of fairness criteria. We explore 4 common such criteria in this lesson. Fairness criteria. Let's begin with the majority criterion. It states, if a candidate wins the majority of first place votes, the candidate should win the election. Head-to-head, also called the Condorcet criterion. If a candidate beats every other candidate in a head-to-head comparison, then that candidate should win the election. The monotonicity criterion. A candidate who wins a first election and then gains additional support without losing any of the original support should also win the second election. Irrelevant alternatives criterion. If a candidate is the winner of an election and in a second election one or more of the other candidates is removed, the previous winner should be the winner. Arrow's impossibility theorem states, it is mathematically impossible. Let me state that again. It is mathematically impossible for any democratic voting method to simultaneously satisfy each of the 4 fairness criteria. Example, use the provided preference table to answer the questions that follow. For this preference table, determine the board account winner. To determine the board account winner, we assign points, 4 points to the first, 3 to the second, 2 points to the third, and 1 to the fourth. Now we multiply those points with the number of votes. Let's do the first ballot for A, B, C, D. 7 times 4 is 28. 7 times 3, 21. 7 times 2, 14. And 7 times 1 is just 7. Now the second ballot, there were 4 of those, so we'll start with 4 times 4, 16. 4 times 3 is 12. 4 times 2 is 8, and 4 times 1 is 4. And for the third ballot, in which there were 2, 2 times 4 is 8. 2 times 3 is 6. 2 times 2 is 4. And 2 times 1 is 2. Now, let's add up all the counts for A. On the first ballot, 28 points. On the second, 8. And on the third, 2. The sum of those points is 38. Let's add up B. On the first, 21. On the next ballot, 16 points. And on the last one, 6. The sum of those 3 is 41. Let's add up the counts of C. On the first, 14 points. On the next one, 12. And on the third one, 8. Sum of which is 34. Then let's add up the D. On the first ballot, D got 7 points. On the next one, 4. And on the third one, 4. So the sum of those 3 is 15. The board account winner is B. 41 total points, more than all the other candidates. Part B, which candidate won majority of the votes? To determine that, we've got to figure out how many total votes first. So we'll add up the numbers along the top row. 7, plus 4 plus 2, that's 13 total votes. Majority is more than 50%. Half of 13 is 6.5. You really can't split a vote in half. So majority number is 7. And according to the preference table, candidate A won the majority of the votes. So on to question C. Which fairness criteria is not satisfied? The majority criterion, which states if a candidate wins the majority of the first place votes, that candidate should win the election. A won the majority and still lost the election. Example, use the provided preference table to answer the questions that follow. Determine the plurality winner. To do that, we need to count of the candidates how many first place votes they got. Reading from the left to the right, I'll start with E. E has 8 first place votes. Looking along that same row for first place votes, I'll look for G. And G got first place votes on the second and third ballot, so that would be 6 plus 4. G got 10. And F got 4. So the plurality winner is G. Part B, determine the pairwise comparison winner. We've got 3 candidates, E, F, and G, so let's pair them up. We'll start with E versus F. In that head-to-head competition, on the first ballot, E wins above F, so that's 8. On the second ballot, F wins above E, so that's 6. On the third ballot, E wins above F, so that's 4 points. And on the last one, F wins above E, so that's 4. E has a total of 12. F has 10. So in this instance, E wins a point. Let's match up E against G. Again, we'll count the votes. On the first one, E's ahead of G. E gets the 8 points. On the second one, G is ahead of E. So G gets 6 points. On the third one, G is again ahead. That's 4 points. And on the last one, E ranks above G. So E gets the 4 points. That's 12 and 10. So in a head-to-head competition with E and G, the winner is E. In this instance, there's no need to do the F versus G because E already has 2 of the 3 total possible points. And so the winner in a pairwise comparison is E. Part C. Which fairness criterion is not satisfied? The head-to-head or Condorcet criterion. If a candidate beats every other candidate in a head-to-head competition, then that candidate should win the election. Example. Use the provided preference table to answer the questions that follow. A. Determine the winner using the plurality with elimination method. The first round of plurality with elimination is counting who has the most first place votes. So we've got candidate H, who has 20, candidate I, who has 16, and candidate J has 14 plus 8, that would be 22. There is no majority winner. We eliminate the candidate with the least votes. That appears to be I. So now I is no longer in the competition. Let's make a new preference table with I gone for round 2. We still have, but this time just first and second place. We got 20, 16, 14, and 8. I need all my lines. So we have H, then J, H, then J, J, then H, and J followed by H again. Let's count the votes. In the first place, H has 20 plus 16, so that's 36. And in the first place, J has 14 plus 8, and that's 22. So in the plurality with elimination, the winner is H. Part B, suppose all of the voters that listed the order J, H, and I change their votes to H, I, and J. Who now wins the election using the plurality with elimination? So let's see, J, H, and I all put themselves behind the H, I, and J. So the H, I, and J will have 28 votes, and that last ballot is gone. Let's do the plurality with elimination again. We have for H, the number of first place votes with the new preference table is 28. For I, first place is 16. And for J, the first place is 14. So in this setting, we eliminate J. So we take J out of the competition, and we have a round 2 preference table with 2 candidates. There's first and second. The ballot counts are 28, 16, and 14, and with J eliminated, first ballot is HI, and the next 2 ballots are IH. Let's count the votes here. In round 2, H has 28 first place votes, but I has 16 plus 14, that's 30. And so when JHI puts all their support behind the HIJ ballot where they were winning anyway, we end up getting I as the winner. So the answer to question C, which fairness criterion is violated, it's the monotonicity criterion. That criterion states a candidate who wins the first election and then gains additional support without losing any of that original support should also win the second election. And finally, let's look at the next example. Using the provided preference table, Part A, determine who wins using a pairwise comparison method. We've got K, L, M, N, so 4 candidates. That gives us 6 head-to-head matches. Let's begin with K first. So we'll do K versus L. And we'll look at K and L. On the first ballot, K wins with 16. On the second ballot, L wins with 10. On the third ballot, K wins and gets the 8 points. And on the last ballot, K wins again and gets 2 more. So in a head-to-head competition between K and L, K gets 26, L gets 10, and that tells us K wins that round. Let's pit K against M. On the first ballot, K wins. On the second ballot, M is ahead. On the third ballot, K is right above M, so K gets the 8. And on the last one, K is still above M, so K gets 2. That count turns out to be 26 for K, 10 for M. K gets another point. Let's match up K with N. We've got K and N. On the first ballot, K wins. On the second ballot, N wins. On the third ballot, N wins, so that's 8 more points. And for the last one, N wins again, so that's 2 more. The final count ends up being 16 votes for K and 20 votes for N. So N wins that matchup. We've got a few more to do. Now we'll move to L. So let's match L with M. Do head-to-head, L to M. On the first ballot, L is ahead, so L gets all 16. On the second, M is above L, so M gets all 10 of those. On the third ballot, M is ahead of L, so M gets 8. And on the last ballot, L is ahead of M, so L gets 2. And in that instance, it is 18. That's weird. But if they split, then L gets a half, and so does M. The next one, we'll pit L to N. Between L and N as in Nancy, on the first ballot, L is ahead, so L gets 16. On the second one, between L and N, L is ahead, so L gets 10. On the third one, between L and N is in first place, so N gets all of the 8. And on the last ballot, N is in first place, so N gets the 2. And so that result is 26 to 10. Between L and M in a head-to-head competition, L wins, so the point goes to L. And we've got one more. That is, we need to do a competition between M and N. Between M and N, on the first ballot, M wins, so M gets all 16. On the second one, M is in first place, so M gets all 10 of those. On the third and fourth, N is in first place on both, so that'll be 8 plus 2. That's 26 to 10. So in a head-to-head competition between M and N, M wins. That's plus 1. K ended up getting 2 altogether. L got 1.5. M also got 1.5. and N got 1. So in a pairwise comparison method, in this preference ballot, the winner is K. Suppose L and M withdraw. Who now wins the election using pairwise comparison method? L and M withdraw. L and M withdraw. L and M withdraw. L and M withdraw. So the revised preference table would look like, we have number of votes, that's still 16, 10, 8, and 2, but with 2 candidates, you only have first and second place. On the first column, we got K, N. On the second ballot, we have N, then K. On the third, N, then K. And on the last one, N and K. It says use a pairwise comparison method. So we need to do K versus N. So we got K and N. On the first ballot, K wins, so K gets 16 votes. And on the remaining 3, N is in the first place, so N gets the 10, the 8, and the 2 for a total of 20. In this instance, the winner is N. Which fairness criterion is not satisfied here? It is the irrelevant alternatives criterion, which states if a candidate is the winner of an election and in a second election one or more of the other candidates is removed, the previous winner should still be the winner. That didn't happen here. These 4 examples illustrate that no voting method satisfies all reasonable conditions, as stated by Arrow's Impossibility theorem.